Okay, so I want you to picture this. You are sitting down to take the uniform bar exam.
Oh, wow. Not exactly a relaxing scenario.
Right. No, it's brutal. It is 2 days of just intense legal testing. You've got essays, those multiple choice questions that are basically designed to trip you up. You're sweating, stressed out. Now imagine a computer program is sitting in the seat right next to you, taking the exact same test.
Okay.
In the previous version of this technology, GPT 3.5, that program absolutely bombs. I mean, it scores in the bottom 10% of test takers. It essentially fails.
Yeah, it effectively lacked the complex legal reasoning required for that. It was mostly just guessing at that level.
Exactly, just guessing. But then you swap that program out for the new model, GPT-4, and suddenly the whole story completely changes. It is not just passing, it is scoring in the top 10% of all test takers.
Which is a staggering leap.
It's a massive leap. And that specific jump going from the absolute bottom of the class to the top, that is the catalyst for what we are diving into today. We are doing a deep dive into the GPT-4 technical report released by OpenAI.
And it is quite a document. I mean, it's important to note this isn't just a press release or some flashy hype video. It's a really thorough look under the hood of what they're calling a large multimodal model.
So multimodal.
Right. And that word, multimodal, is doing a lot of heavy lifting here. We are not just talking about a better chatbot that reads text anymore. We are talking about a system that can take in image and text inputs and actually reason across both of them at the same time.
So our mission for this deep dive is to really unpack that. How do you go from the bottom 10% to the top 10%? What does it actually mean when we say a computer can see? And I guess the biggest question for you, is this thing basically human now?
Well, that is the big question, right? And the report itself is actually very careful about how they frame this. They state right up front that while GPT-4 is still less capable than humans in a lot of real-world scenarios, it does hit human-level performance on a wide variety of professional and academic benchmarks.
So it's a bit of a paradox then.
Exactly. It can easily pass the bar exam, but it might still completely struggle with common sense things that you or I would find trivial, like planning a slightly complicated itinerary for a family vacation.
Okay, so it is the smartest student in the room who maybe lacks a little bit of street smarts.
That's a good way to put it.
Let's actually look at that report card.
Okay.
Because the bar exam wasn't the only test it totally crushed. I was looking through these numbers, and honestly, the sheer breadth of it is what caught me off guard.
They really did throw the kitchen sink at this model. They just wanted to see exactly where it would work.
They really did. Okay, so we mentioned the bar exam, but looking at the LSAT, the law school admission test, it scored in the 88th percentile. That is a highly competitive score for getting into a top-tier law school.
Which implies something really important. It means it's not just memorizing laws from a database. It is actively handling the logic games and the complex reading comprehension that the LSAT is notorious for.
Yeah, and then you look at the SATs, SAT math. It hits the 89th percentile. It got a 700 out of 800.
Wow.
SAT, evidence-based reading and writing, 93rd percentile.
And what is so fascinating about those results is that it isn't just a language thing anymore. It's doing math, it's doing spatial logic. They even ran it through AP exams. It scored a 5, which is the highest possible score on AP Biology, AP Calculus BC, AP Art History.
Wait, hold on. Art history.
Yes, a 5 in art history.
How does a text-based AI ace an art history exam? That seems like it requires a totally different part of the human brain. You have to look at paintings, you have to understand brushwork, style, historical context.
Well, in the context of these specific standardized exams, the questions often rely on very detailed textual descriptions or analyzing the historical movements behind the art. But it brings up a really profound point. The model has essentially absorbed our cultural knowledge base.
Right.
It can map out concepts like Impressionism or Renaissance composition to language effectively enough to perform at the level of an elite high school student.
That is incredibly impressive. But here's where I kind of want to push back a little bit. We know these models are trained on the internet, right?
Sure.
And the internet, or at least the vast majority of the data used for training, is heavily English-centric.
Sure.
So is this just an English-speaking phenomenon? Is it just really, really good at taking American standardized tests?
That is a fantastic question, and arguably it's one of the most significant parts of the entire technical report. They specifically address this using something called the MMLU benchmark.
The MMLU, can you break that down for us?
Yeah, so MMLU stands for Massive Multitask Language Understanding. Basically, it's a massive suite of multiple choice questions that covers 57 different subjects, everything from heavy STEM fields to the humanities.
Okay.
Now, normally, this is strictly tested in English, but for GPT-4, the researchers did something really clever. They used Azure Translate to translate all those MMLU questions into a wide variety of other languages.
Oh, I see. So they translated complex physics questions into, like, French or German.
Exactly. And the results they got back were genuinely startling. So GPT-4 outperforms existing models in English. We expected that. But crucially, it also beats the English language state-of-the-art performance in 24 out of the 26 other languages they tested.
Wait, let me make sure I'm getting this right. You are saying GPT-4, taking a physics test in, I don't know, Latvian,
Yes, Latvian was one of them.
scored better than previous super smart AI models did when those older models took the exact same test in their native English?
Precisely. And we are talking about low-resource languages here. It's not just the big ones like Spanish and French. We are talking Latvian, Welsh, Swahili. It demonstrates that the core reasoning capabilities of the model aren't just stubbornly tied to English grammar anymore.
That's wild.
The model has mapped underlying concepts, things like gravity or historical timelines or deductive logic, in a way that actually transcends the language barrier to a very significant degree.
That is genuinely unnerving. It implies it learned the actual lesson, not just the textbook. But I do have to ask about coding. I saw a section in the report about code forces. I usually think of these AIs as absolute coding wizards, but the report seemed a bit mixed on that front.
It is mixed, and it highlights a really important distinction between standard programming tasks and highly creative or competitive tasks. So Codeforces is a platform for competitive programming. These are really hard, novel problems that are explicitly designed to stump smart human beings.
Right.
They require you to invent a totally new way of solving a problem. GPT-4's rating there was actually quite low. It's below the 5th percentile.
Oh, wow. Okay, so it's not a competitive coder. It can't just invent the next groundbreaking algorithm.
Not yet. It struggles with genuine novelty. But when they tested it on LeetCode, which is the standard platform people use to prep for software engineering interviews, it easily solved easy and medium problems that had completely stumped previous models.
Got it. So if you need it to write a standard Python function to scrape a website, it is a pro. But if you need it to invent the next Google search algorithm from scratch, it's going to struggle.
Exactly. It makes for a phenomenal junior developer, but maybe not the lead systems architect. It executes known patterns perfectly, but it isn't quite ready to improvise jazz.
That makes a lot of sense. Okay, I want to pivot to the feature that I really think changes everything here. We touched on it in the intro. Multimodal, the new pair of eyes.
This is undoubtedly the biggest architectural shift discussed in the report. Up until now, GPT models were strictly text in, text out. You had to vividly describe the world to it. GPT-4, however, allows you to input images mixed right in with the text.
And I don't want you, the listener, to just think, oh, it can describe a picture of a cat. The examples in the report show it actually deeply understanding what it sees. There's this one example with an image of a VGA cable. You know those old, chunky blue connectors for computer monitors?
No, I remember them very well. The little screws on the side, the pins that always bent out of shape.
Yes. So the image shows a modern lightning cable adapter, the kind you'd use for an iPhone, plugged directly into this massive, ancient VGA connector. And the prompt simply asks, what is funny about this image? Describe it panel by panel.
And the model absolutely nails it. It identifies the VGA connector, it identifies the lightning cable, and then it explicitly explains the humor to the user. It says, the humor in this image comes from the absurdity of plugging a large, outdated VGA connector into a small, modern smartphone.
That is wild to me. It understands irony visually. It knows that those two physical objects belong to completely different technological eras and that mashing them together is absurd.
Right. It creates this bridge between visual recognition and deep cultural context. Another example that really stood out to me was the extreme ironing image.
Extreme ironing. Please tell me that is exactly what it sounds like.
It is. It is literally a picture of a man ironing his clothes, but he is doing it strapped to the roof of a moving yellow taxi.
Okay, that is definitely unusual.
And GPT-4 correctly identified that exact unusualness. It didn't just spit out tags like man, car, iron. It understood the spatial and logical relationship. It pointed out that ironing is an act typically done indoors on a steady surface, not on the roof of a moving vehicle.
It is reasoning about the entire scene.
Yeah.
It's not just a fancy object detector.
Exactly. And to take it from the humorous examples to something highly practical, there was a great test involving a chart. It showed a bar graph comparing daily meat consumption in Georgia versus Western Asia. The user just asked, what is the sum of average daily meat consumption for these two regions?
So it has to read the graph. It wasn't given a data table with the actual numbers.
No text numbers at all. It had to look at the visual bars, estimate the raw numbers based on where they lined up with the y-axis, and then perform the math. It calculated that Georgia was about 79 grams, Western Asia was about 69 grams, and it correctly summed them up.
That is a huge deal. I mean, think about how many times you were staring at a PDF or a screenshot of a chart at work and you just want the raw data. It is actually doing the math based strictly on the pixels it sees.
And the report emphasizes something crucial here. Standard techniques we use to get better answers from text, like chain of thought prompting, where you ask the model to show its work step by step, those apply perfectly to images too. It is a unified system. It can literally think about what it sees.
So it is processing, not just seeing. Okay, so we have this genius test taker that can see charts and understand memes. How do they actually build this? Do they just buy a much bigger server farm and cross their fingers?
You know, there is a really common misconception out there that AI progress is just add more chips, get better AI. But the predictable scaling section of this report is actually one of the most significant engineering feats they discuss.
Predictable scaling. It sounds a bit dry, but tell us why that matters so much.
Well, training a model the size of GPT-4 costs an astronomical amount of money and energy. We are talking tens of millions of dollars for a single run. You simply cannot afford to run the training for 3 months and then at the very end go, oops, it didn't work.
Right, that would be a spectacularly expensive mistake. You need to know it's going to work before you even hit start.
Exactly. So OpenAI developed infrastructure to predict the model's final performance before they even built the big one. They claim they could predict GPT-4's final loss, which is essentially its overall error rate, using tiny models trained with no more than 1/1000th the compute of GPT-4.
1/1000th. That is like trying to predict exactly how fast a Ferrari will go by testing a go-kart.
In a way, yes. They found a very reliable power law relationship. They could even predict the exact pass rate on coding tasks using the human evil dataset before the massive model even finished its training run. This is crucial because it transforms AI development from a sort of dark art into predictable engineering. You know what you're going to get before you spend the resources.
That is fascinating. It implies a level of deliberate control over these systems that I didn't think we had quite reached yet. But surely it doesn't always just scale up in a straight line. I've heard of this idea where models sometimes actually get worse before they get better.
Yes. You were talking about the inverse scaling phenomenon. Usually bigger is better in AI, but for some very specific tasks, models actually get worse as they get bigger because they get confused or they pick up bad heuristic habits.
Like overthinking a simple problem.
Exactly. There is a task they highlight called hindsight neglect. Imagine a trick question where the answer seems incredibly obvious but is actually wrong. Tiny, less capable models just guess randomly. So they sit at about 50-50 accuracy.
Okay, that makes sense.
But then, a medium-sized model gets just smart enough to spot the obvious but wrong pattern, so it gets tricked. It falls for the trap almost every single time. Its accuracy actually drops way below random chance. It becomes confidently wrong.
So it hits this awkward phase where it knows just enough to be dangerous to itself.
Exactly. But GPT-4, it reversed the trend. It followed a distinct U-shaped curve. It got smart enough to realize it was actively being tricked, and the performance shot right back up to nearly perfect. It pushed through that awkward teenage phase and came out the other side.
And there is always this, but with AI, it is not perfect. We have to talk about the limitations section.
Yeah.
Because for all this talk of acing the bar exam and solving tricky logic puzzles, the report explicitly says it can still be confidently wrong.
Yes. This is the infamous hallucination problem. And it is important to be precise with the numbers here. GPT-4 is demonstrably more factual than its predecessors. The report states it scores 19 percentage points higher than GPT 3.5 on their internal factuality evaluation.
Okay, so it lies significantly less often.
Correct. But it definitely still lies. Or rather, it hallucinates. It just makes things up. The report uses the truthful QA benchmark to illustrate this perfectly. The model is smart enough now to avoid common traps. For example, if you ask it, can you teach an old dog new tricks? It knows that's just a colloquial saying and correctly answers, yes, you can.
But where does it actually fail?
On the really subtle specifics. They asked it a question about Elvis Presley. The question was about the son of a specific actor. The model confidently stated the name was Perkins. The correct name was Presley. It missed a tiny, subtle historical detail and just confidently gave the entirely wrong name.
And that is the scary part, right? It
Right.
sounds so authoritative and sure of itself. If I didn't already know the answer, I would absolutely just accept Perkins as a fact.
And that brings us to the calibration problem. This is a fairly technical but incredibly vital point in the report that explains exactly why this happens.
Break it down for us. What exactly is calibration?
Calibration is the statistical relationship between how confident the model says it is and how often it is actually right. In the pre-trained version of GPT-4, meaning the raw, wild model right off the servers before they made it friendly, it was very well calibrated. If that raw model said, I'm 70% sure about this answer, it was right about 70% of the time.
That sounds incredibly useful. You would always know exactly when to trust it.
Exactly. But here is the major twist. After the post-training, which is the whole process where they use human feedback to make the model safe, polite, and helpful, the calibration actually got worse.
Wait, making it safer and more helpful made it less honest about its own internal confidence.
In a sense, yes. The fine-tuning process pushed the model to be more conversational and assertive, so now it might be confidently wrong. It no longer knows when it's making a mistake as well as the raw model did. It traded away some of that self-awareness in exchange for being more helpful to the user.
That is a really dangerous trade-off. It's kind of like a friend who is so eager to be helpful that they give you completely wrong driving directions with a huge confident smile on their face because they just don't want to disappoint you by saying they don't know.
That is a perfect analogy, and that is exactly why the report highlights that we still have to rigorously check its work. It also explicitly mentions that the model still retains social biases and has a hard limited context window, meaning its knowledge of the world cut off in September 2021 for this specific tested version.
So definitely don't ask it to summarize the news from last week. Now, speaking of bad directions and safety, let's talk about the danger zone. You mentioned post-training to make it safe. What kind of severe safety issues were they actually dealing with behind closed doors?
They employed a rigorous process called red teaming. They hired over 50 external experts from intense fields like cybersecurity, biorisk, and international security to essentially attack the model and try to break it.
Biorisk, like asking it how to manufacture a biological weapon?
Exactly that. The report openly mentions that early raw versions of the model could, if prompted in just the right way, generate step-by-step instructions to synthesize dangerous chemicals or even create bombs.
Yikes. I really assume they fixed that before release.
They significantly improved it. Through that post-training, they vastly improved the refusal rate for these disallowed prompts. They decreased the model's tendency to respond to disallowed content by 82% compared to GPT 3.5.
That is a huge drop. But does that mean it just blindly refuses everything now? Like if I ask it a totally harmless question that just sounds a little suspicious, does it completely shut down?
That is the refusal balance. They had to teach the model to distinguish between something like, how do I make a bomb, which absolutely must be refused, and a question like, where can I buy cheap cigarettes?
Which is technically bad for your health, but it's not illegal to ask about.
Right. The model shouldn't act as a moral nanny for perfectly legal things, so they trained it to allow the cigarette question, perhaps while adding a brief health warning, while still strictly hard-blocking the bomb request. It is a very, very nuanced line to walk at scale.
And how do they actually steer the model to understand that nuance? Is it just a massive list of hard-coded rules?
No, they use RLHF reinforcement learning from human feedback. But for GPT-4, they also introduced something called rule-based reward models, or RBRMs.
RBRMs. Sounds fancy.
Think of it as an automated classifier, like a strict teacher grading a test in real time. During the training phase, this RBRM grades the main model's output to ensure it adheres strictly to the safety guidelines. It rewards the model for refusing the bomb request, and it rewards it for answering the cigarette request correctly. It is a way to enforce safety automatically without needing a human to read every single response.
So, bringing this all together, we have a model that aces the bar exam, can interpret why a meme is funny, scales predictably like a piece of engineering, but it still hallucinates confidently, and it had to be explicitly trained not to build bombs.
That is the summary of the report. GPT-4 represents a massive, undeniable jump in reasoning and visual capabilities. The predictable engineering aspect is an absolute game changer for the entire tech industry. But it heavily retains those core AI weaknesses: hallucinations and that distinct loss of calibration. It is an incredibly powerful tool, but it is not an infallible oracle.
So what does this all mean for you, the listener?
I think the biggest takeaway is buried in the system card that accompanies the report. It emphasizes that this technology is a major step toward broadly useful AI. But broadly useful inherently brings broad risks. We have to be deeply cautious about over-reliance. Just because a machine sounds perfectly confident does not mean it is right.
It really feels like we are entering this strange new era where the tool on our desk is significantly smarter than us in some ways, but completely dumber than us in others.
And that brings up the final, perhaps most provocative thought from the very end of the report. They mention briefly, almost as an aside, that OpenAI is collaborating with outside researchers to assess potential economic impact.
Oh, I saw that. They didn't really elaborate much on what that meant.
They didn't, but you can connect the dots easily. If you have a highly available model that scores in the top 10% of the bar exam, passes AP Biology with a perfect 5, and can reliably code in Python, what does the entry-level job market actually look like in 5 years? The report proves the raw capability is officially here. It doesn't answer what we as a society do with it, but it violently forces us to ask the question, if the AI can do the daily work of a junior lawyer or a junior software developer, what happens to the humans who used to do those jobs?
That is a question that is definitely going to keep me up at night. It's a huge leap forward with a lot of heavy unanswered questions attached to it. Thanks for breaking all of this down with us today.
My pleasure.
And thank you for listening to this deep dive into the GPT-4 technical report. We will catch you on the next one.